Canned meat is one of the most durable and widely distributed food products ever invented, capable of sitting safely on shelves for years while remaining ready to eat within seconds. Yet, behind every sealed tin is a powerful industrial process that blends meat science, precision mixing, high-pressure thermal sterilization, and packaging engineering designed to prevent contamination at all costs. What looks like a simple metal can is actually a miniature survival system. Food preserved with heat, sealed against air, and protected by layers of quality control. And today on the How Factory, we're going inside modern canned meat factories to see exactly how canned meat is made, from raw pork to sealed tins shipped worldwide. The story of canned meat begins with one of the most important food innovations in human history: canning. In the early 1800s, governments and armies needed food that could survive long journeys without spoiling. Experiments proved that heating food inside a sealed container could destroy microbes and preserve it for months or years. This discovery transformed global trade, exploration, and military logistics. Over time, canning expanded beyond vegetables and soups into meats, creating shelf-stable protein that could be shipped anywhere without refrigeration. Today, canned meat remains critical for emergency supplies, military rations, remote regions, and everyday kitchens. Modern canned meat production begins at the receiving stage, where raw pork arrives at the processing facility under strict cold chain control. The meat is transported in refrigerated trucks and unloaded into temperature-controlled rooms. Food safety begins immediately. Every batch is checked for temperature, appearance, and documentation. Samples may be tested for microbial levels, fat content, and moisture. Only meat that meets strict standards moves forward because canned products depend on absolute safety and consistency. Once approved, the meat enters trimming and preparation. Workers and machines remove excess connective tissue, cartilage, and unwanted fat to achieve the desired texture. Different canned meat products require different ratios of lean meat to fat, and this balance matters. Too lean and the product becomes dry and crumbly. Too fatty and it becomes greasy and unstable. Trimming lines operate quickly, but precision is constant. After trimming, the pork is ground. Industrial grinders push meat through plates that cut it into small, uniform pieces. Grind size is carefully chosen depending on product style. Finer for smooth, loaf-style canned meat, coarser for chunkier varieties. Grinding also increases surface area, which affects seasoning absorption and protein binding during cooking. Temperature control is critical here. If meat warms too much during grinding, fat can smear and protein structure can break down, harming texture later. Next comes mixing, the stage where canned meat becomes a formulated product rather than just ground pork. Ground meat is transferred into massive stainless steel mixers. Salt is added first because it activates proteins that help the meat bind together into a stable structure when heated. Additional seasonings are added depending on the recipe, such as sugar, pepper, spices, curing agents, and flavor extracts. Some canned meats include starches or stabilizers that help hold moisture and create a firm, sliceable texture. Mixing is carefully timed and controlled. Overmixing can create rubbery texture, while undermixing causes uneven seasoning and weak binding. Industrial mixers need the meat under controlled temperature to keep it cold and stable. Some lines use vacuum mixing to remove air pockets, improving texture and preventing oxidation. At this stage, meat may be partially cooked depending on the product. Some canned meats are packed raw and cooked entirely in the can during sterilization. Others are pre-cooked slightly to set structure and reduce shrinkage. Cooking parameters depend on recipe and safety design. Now comes filling, one of the most precise and continuous stages in the factory. Empty cans arrive in bulk and move along conveyor lines. They are cleaned using air jets or rinsing systems to remove dust or metal particles. Sterility is critical. Any contamination entering the can could compromise shelf life. The meat mixture is portioned into cans using automated fillers. Depending on product type, the meat may be packed as a smooth paste, pressed into shape, or dropped as chunks. Filling machines must deliver exact weights while maintaining speed. Underfilled cans violate regulations. Overfilled cans prevent proper sealing. Some products include added broth, gelatin, or fat layers to improve flavor and moisture retention. Once filled, cans move to vacuum sealing or exhausting systems. Removing air is essential because oxygen accelerates spoilage and corrosion. Some factories use steam flow to drive out air, while others use vacuum chambers. The goal is to create a low-oxygen environment inside the sealed can. Next comes seaming, the moment the can becomes a sealed container. Lids are placed onto cans and sealed using double seaming machines. These machines roll the lid and can edge together in a tight mechanical lock, creating an airtight seal. Seam integrity is critical. A microscopic defect can allow bacteria to enter and ruin an entire batch. That's why seam measurements are monitored constantly with sensors and manual inspections. After sealing, cans are washed externally to remove residue and then move into the most important step: thermal processing, also known as retorting. Retorts are massive pressure vessels designed to sterilize canned food. Cans are loaded into racks and placed inside retort chambers. Steam and pressure raise internal temperatures high enough to kill bacteria, including heat-resistant spores. This is what makes canned meat shelf-stable for years. Retorting is not just heating, it's controlled, calculated sterilization. Time, temperature, and pressure are engineered based on product thickness, fat content, and size. Too little processing is dangerous. Too much processing destroys texture and flavor. Modern retorts use computerized controls to follow exact sterilization curves, ensuring safety while preserving quality. As cans heat inside the retort, the meat cooks fully. Proteins set, fats melt and redistribute, and the mixture forms its final structure. This is where canned meat becomes firm, sliceable, and ready to eat. Once the thermal cycle is complete, cans are cooled rapidly with water sprays or cooling systems to stop cooking and stabilize internal pressure. After retorting, cans enter drying conveyors and then inspection. Quality control is intense at this stage. Automated systems check can shape, seam quality, weight, and seal integrity. Cans with dents, swelling, or seam defects are rejected immediately. Swelling is a major warning sign. It can indicate gas production from bacterial activity, which means the product is unsafe. Cans are then coded with batch numbers and production dates, allowing full traceability. Labels are applied or printed directly onto cans. Some products are packed into cardboard sleeves, while others are bundled in multi-packs. Final packaging is done using automated case packers that load cans into cartons. Cartons are sealed, labeled, and stacked onto pallets by robotic palletizers. Finished pallets move into warehouses where product can be stored at room temperature, one of the greatest advantages of canned meat. Behind the scenes, sanitation and food safety systems operate continuously. Meat processing facilities follow strict hygiene protocols, stainless steel surfaces, frequent cleaning cycles, controlled employee access, and environmental monitoring. Because the product is meat-based, contamination risk is high, and factories rely on strict process discipline to maintain safety. Sustainability is also part of modern canned meat production. Waste meat trimmings are reused where possible. Water used in cooling and cleaning is filtered and recycled. Heat recovery systems capture energy from retorts and boilers to improve efficiency. Even the cans themselves are designed for recycling, making metal packaging one of the most reusable systems in food production. What makes canned meat manufacturing remarkable is how it turns a highly perishable product into a shelf-stable food that can survive extreme conditions. Raw pork would spoil quickly without refrigeration, yet once sealed and sterilized, it becomes safe and edible for years. This process is a triumph of industrial food science and packaging engineering. From chilled meat entering grinders to precisely mixed formulations, from airtight seams to pressurized retort sterilization, the journey of canned meat is a carefully guarded system where safety is the top priority and consistency is everything. And that is exactly how canned meat is trimmed, ground, mixed, filled, sealed, sterilized, inspected, and shipped, transforming raw pork into sealed tins that can feed millions anywhere in the world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, processes, and factories behind everyday foods.